chocolate ball.
And your warm-up asked you to bring that out as well. Tuesday, we're doing 2.2, which is hats. Wednesday is 2.3 scale factor. And Thursday is area and perimeter packet. Friday, we'll be finishing up that packet. We will see when Mrs. Iverson is here, when I'm here. It might be a little bit different this week because of the sick kid situation, but we'll see. Nonetheless, once you finish that up, you can go ahead and take out your coordinate graphing from last week. And the very first thing that you can do is put your name on it. So do that. You're filling out your agenda, and you are putting your name on your coordinate graphing from last week. Just to clarify, you do not have to turn in the sheet that has like the points listed on it. You only have to turn in the finished product. And as a reminder, if you chose one from this list, you only have to do one. If you did choose or create your own or Tuba Factory, you have to do another one with it from anywhere. Okay, so just clarifying, if you created your own, that's great. You need to do one more of any of them. I don't care which. Okay, when you're ready, you can staple them in, turn them in, make sure your name and period number is on it. Now that that's out of the way, go ahead and push that to the side. We will have time potentially at the end of the class to work on that if you finish the activity. Jack Dixie? All right. Somebody with a raised hand, tell me, what are some tricks to plotting points on a graph? So if I'm asking you to plot the point 2, -3, just remind me, what does it take to plot that point? Ethan?
Wait, 2, -3?
Huh?
You should know where your numbers are on the X and Y axis.
Right. Okay, so like,
Know which one is which, and which one to go first.
so which one is which?
The X is the one going across, and the Y is going up and down, right?
Yeah.
Yes, yes.
Okay.
I see what you're saying. Yes. Good. And what about this?
The right side is positive, like a number line, and the left side is negative, like a number line.
Correct. Okay, so we think of the x-axis like a number line.
Yeah.
We can think of the y-axis like a thermometer, right? Up is positive, down below the x-axis is negative. But now which of these, like 2, -3, which one of those is x, which one is y? Gage?
The first one's X, the second one's Y. I also have a question.
Go for it.
In a 3-dimensional standpoint, wouldn't it, like forward would be Z? There's X, Y, and Z.
Yes.
Okay.
We're not going to talk about that, but yes, you're right. We can talk about it later if you're interested. Okay, so let's plot this point. What are the tricks? How do I do it? What do you remember? How do I know where to plot my point? Gabrielle?
You plot your X first, and then you find where your X is, and then you find your 2Y.
Yeah. You start with the 2 and you go over 2. Now do I put a dot there?
No.
No, because I need both of these pieces of information to plot one point, right? This is not a point and this is not a point. This is one point, right? So I go over 2 and then what? Down 3. And that's the point. Okay. You remember that? That's just a quick little review for what we are doing today. Let's see if there's anything else. Today, we're going to watch a short little video that, let's see if I can find it, is about animation. And this is actually true. In the real world of animation, they use coordinate points to animate. Did you guys know that?
Yeah.
Let me unmute it. And then move the coordinate. You can zoom in, Marina, because screen so you can see it.
That looks like it.
Oh,
Yay! I love
hey,
this
That's
sound.
pretty good.
okay. Here we go.
When creating motion graphics for a video or a computer animation, programmers need to understand how to place and move objects on a coordinate grid. This allows them to be more creative and efficient. Take this situation for example. When building graphics for a math program, the editor starts with the basic figure placed at the intersection of the X and Y axes. We could simply fade the graphic up like this, but that's kind of boring. Moving the graphics around in space and enlarging or shrinking them is much more visually engaging. Let's start by deciding where we want the graphic to end its movement, say at 100 units from the origin along the y-axis. We can also try some x-axis movement. And after a bit of work, we end up with graphics that are much more interesting to watch. Understanding the x and y axes on a coordinate grid assists designers and animators in doing their jobs. It lets them have a little fun as well.
Alright. Now, that was a little bit of a really like amateur, right, of animation, but it gives us an idea. Did you guys know that they use coordinate grids to do animation? And what they do is instead of plotting every single point every single time, is they create rules. And the rules will tell them what to do or how the points are all going to change, and the computer puts in all the little points. That'll make a little more sense in just a few minutes. But first of all, let's chat. Did you guys see that when they took the little triangle puppy thing, did you guys see that when they like expanded it, did you guys see how they changed it?
Yeah.
Well, first of all, as it was moving here, it was really amateur because it stayed exactly the same shape and exactly the same size, right, the whole time, which means that it is mathematically what?
Correct.
Say it loud. Similar. It is mathematically similar because it stayed the same shape, same angles, right? Now, did you guys also see that when they took it and like they expanded it and made it smaller? That would be, well, when they did it like this at first, it stayed the same shape and the same angles, just a different size, right? And that is still mathematically similar. Then they made it kind of look like a fun house and distorted it, right? Where they took it and made it like really tall and skinny or really short and fat or whatever. Those made it is no longer then mathematically similar, right? Because the angles have changed and the shapes have changed as well. So today, well, let's just think of this. Think of, okay, I'm gonna use my kids. You guys are past this, but have you ever watched Paw Patrol?
Oh yeah.
And so if you have, listen up. Nope. Waiting. If you have, imagine one of the puppies like Marshall. And if you haven't seen it, that's fine. Just imagine a puppy. It would be very, very weird if Marshall suddenly, as he's animating and doing things, becomes like fat skinny, right? It's very important for animators to keep their animations similar, right? And if they zoom in, if you imagine this for animation, they're not zooming a camera in, they're making the picture larger. And it has to stay similar, right? Otherwise it looks like you're in a carnival funhouse.
Don't search up how they make Paw Patrol. It looks really weird as it makes.
It would be, yeah, exactly. So they need to make sure that they don't distort it and they keep things similar. So today we're going to do something along the same lines, where we are going to, well, we'll read through this. Oops, that's not what I wanted. Okay, here you go. Zach and Marta's computer game involves a family called the Wumps. The members of the Wump family are various sizes, but they all have the same shape and angles. That means they are similar. Mugwump is the game's main character. By enlarging or reducing Mug, a player can transform him into other Wump family members. But if they're no longer similar, they're what we're going to call imposters. Somebody's trying to come in Thanksgiving that doesn't belong there. Zach and Marta experiment with enlarging and reducing figures on a coordinate grid. First, Zach draws Mugwump on graph paper. Then he labels the key points from A to X and lists the coordinates for each point. Marta writes the rules. This is what we're talking about. Instead of like plotting every point, Marta's saying, I'm going to make life easier. We're just going to create a rule to change Mug's size. That's it. Okay, so we're going to see how the rules affect it today by doing the work. Oh, it's not here. So, here's what's going to happen. You're going to get a sheet like this. Every single person is going to start by plotting Mugwump. Now, this is exactly like what we did last week with our coordinate grids, with our coordinate graphs. You're going to create a picture of some sort. You're going to start by plotting the first point, 0, 1. So over here, I'd go 0 on the x-axis and up 1, right? Okay, the next one, 2, 1. I'm only doing 2 points. And then connect, right? If you see this part, this blue part that says part 2, start over, at that point, that's like a stop in what we did the other day. Does that make sense? So you're going to start a new line at that point. Ethan?
This mug looks like a mug.
You're about to find out. You will draw in mug, and you'll notice, Evan, that at the very bottom it says make a dot, Ben. At the very bottom it says make a dot, so that means you're not connecting it to anything, you just put a dot at the point that it tells you to. So you'll create mug then. Then you'll choose 2 other characters. I don't care which ones, but you must choose 2 other characters. So let's say I chose Zug and Glug. Let's say those are the 2 that I'm going to do. So I'm going to do mug first, then I'm going to do Zug and Glug, but wait a minute, they don't have points. Any ideas, Maria, if you can like zoom in, if you know how to do that, up to the rules and stuff, how are you going to create the points for Zug? I have 2 points for Zug, but how am I going to know what the points are going to be? About it? Ideas? Eli?
I'm gonna do it times 2.
Why?
Because this is 2x and 2y, like in algebra, it's 2 of that thing.
Yes, so 2x means it's going to be 2 times the x coordinate. We always go back to Mug, he's the original. So we're going to say 2 times the x coordinate. So 2 times the x, so 2 times 0 here is still 0, right? And 2 times y, so 2 times 1 is 2. Do you see how they got that? Same thing here, 2 times x, 2 times 2 is 4, 2 times y, 2 times 1 is 2. Okay, somebody tell me what is the next point going to be? If it's 2 times the x coordinate, so this next point is 2, 0. So what is the next point going to be? Lizette? 4, 0, because it's 2 times x and 2 times y. Does everybody follow?
Yes.
Okay. So you're going to fill all of this in. You're basically doubling each of the numbers here, right? And creating your new points, and then you're going to graph it. Yes, Jack?
Why do you?
Well, because it's a new character, and that's the rule that we're following from Marta to see how it affects the animation. Then we're going to look at Glug. Okay, Glug is a little bit different. His rule is x, 3y. Any guesses at what that means? That's the rule. So that means you're going to go back to Mugwump, but what are you going to do? How do you get the next point? X, 3y is the rule. Okay, Mia?
You repeat the first number or x the same
Uh-huh.
for Mugwump, but then you would keep y, but then you would multiply y times 3.
Yes.
Oh, okay.
So the x is a 0, so it's going to stay a 0, right?
Yeah.
And the 3 times y, so 3 times 1 becomes 3. Does that make sense? So tell me what's the next point going to be. If it's x, 3y, and the point is 2, 1. Point is 2, 1, and the rule is x, 3y. 2, 1. Vanessa? 2, 3, because it's just what the x coordinate is, 2. And then 3 times the y coordinate, 1 times 3 is 3. And if you have questions, you can ask me or people around you to help you. Then you're going to graph them. Now the last line of business that we need to do is after I pass these out, and the sub can pass this out in 8th period right now as well. The last thing that we need to do is everybody is going to choose two figures outside of Mug that they are going to draw. However, each wump needs to be accounted for within your group. So at least each of these has to be done at least once between the 2, 3, or 4 of you.
I got